Okay, I'm going to show you how we can solve this particular problem here. So this here is a cantilever beam, and it has a negative 2 kilonewton force here and a 6 kilonewton force per meter uniformly distributed load. Now this is 1/2 meter wide, so it acts like a 3 kilonewton meter force going down the center. It's positioned, this uniformly distributed load is at 0.3 meters from the edge. Alright, and this is the reaction force here. And we would need to solve for this. And it's also a reaction moment. So to find that, the reaction force at this point here must all sum up to 0. So we have negative 2 plus negative 5 plus the reaction force must equal 0. So the reaction force itself is 5 kilonewtons in the positive direction. Now for the moments, we have, if you look here, there's a counterclockwise moment occurring. So we have 2 kilonewtons going down at a distance of 0.9 meters. So negative 2 times 0.9 plus the uniformly distributed load, which acts like a 3 kilonewton force at a distance of 0.55 meters, plus the moment in the clockwise direction must equal 0 at this point here. So our moment that is at this point here, if we solve that on the calculator, let's have a look. So we have negative 2 times 0.9 plus negative 3 times 0.55. So we have all that is on one side and the moment's on the other. So our moment is a positive of 3.45 kilonewton meters. Okay, so our moment at A is 3.45 kilonewton meters. Okay, so now that we've solved that, let's work first on finding our shear forces. So, the shear force at point E, and I'll call it prime, so that's just to the left of that point, is the sum of all forces. So the sum of all forces just to the left of E is 0. So let's do the shear force at E itself is still 0. Okay, let's move on to the shear force at point D prime, so that's just to the left. So just to the left of that we have 0 newtons of force, and the shear force at point D just to the right of that point would be a negative 2 kilonewton force. Okay, so let's continue on. Now we have the shear force at point B is equal to negative 2 kilonewtons plus, at this point here there's a negative 3 kilonewton force, so negative 3 kilonewtons. So that equals negative 5 kilonewtons at that point. Okay, and the shear force at point B itself, just to the right, is the same thing. So once again, negative 2 plus negative 3. Okay, now at point A prime, just to the left of it, you have negative 2, negative 5. Negative 2, negative 3, so it's negative 5 kilonewtons. Okay, and at the force just to the right of it, you now have to count in the 5 kilonewtons. So you get negative 2, negative 3 plus 5 is 0. Okay, so there's no shear force at this point here. Alright, now let's sort out our bending moments. So the bending moment at point E here is the sum of the moments to the left of it. So at that point we have no moments. The bending moment at point D, put a finger on that point, still there's no forces, so we have 0. The bending moment at point C, we have 2 kilonewtons times 0.1 meters is the distance to point C. So, and that's going in the counterclockwise direction. So we have negative 2 kilonewtons times 0.1 meters, which is negative 0.2 kilonewton meters. Okay, the bending moment now at point B, here, you have negative 2 times 0.6 meters plus we have this shear force, the force in the center, which is acting like a 3 kilonewton force times the distance of 0.25, half that distance. So we have 3 kilonewtons times 0.25, and that's a negative force. So at bending moment B, you have negative 2 times 0.6 plus negative 3, let's fix this up, times 0.25. So we have a bending moment of negative 1.95 kilonewton meters. Okay, now at bending moment at point A, you have 2 kilonewtons times 0.9 meters. Plus you have the 3 times, now that distance is 0.55. So plus negative 3 kilonewtons times 0.55. So we get a grand total of negative 2 times 0.9 plus negative 3 times 0.55. Now you have a negative 3.45 kilonewton meter shear force there. Bending moment. Now, if you think just to the right of that point, you have now all of that, plus then you have a positive moment. So that means that the bending moment, we'll call this A prime, so just to the right of it, is now equal to negative 3.45 plus positive moment at point A. So that's 3.0. Okay. All right, now how do we graph this? So let's make a graph now. So now I'm going to load up and make a graph that is 10 centimeters long. Okay, and point B is located 0.3 mil there, point C is there, point D, point E. Okay. So we'll call this E, D, C, B, A. So this is the shear force. So let's start. Shear force E starts at 0, then just to the right, it's also 0. Shear force D is 0, and then it goes from 0 to negative 2. So 1, 2, negative 2. Okay, now for shear force at point, I forgot one. Oh, let's see. D, D, C. Shear force D. Okay, so shear force at point C, it doesn't actually matter, it's going to move up anyways. So shear force at point C is also negative 2, so let's put that in. Shear force at point C, just to the left and just to the right are the same, so that's going to be negative 2 kilonewtons. Alright, so shear force at point 2 is, okay, and then we got shear force at point B. So point B is here. We start at negative 5 and we finish at negative 5. So let's see, that's 1, 2, 3, 4, 5. Okay. Now at this point, we're going to go to shear force at point A. So it starts at 0.5 and then goes to 0. So how does it look? Well, we first start here. We're going to go across, down, across. All right, and then we have a uniformly distributed load, so that means it's going to be an angle. Okay, and it goes over to A, and it goes down. So that is our shear force diagram. Now we'll do the bending moment diagram. So let's start at E. E is 0, D is 0. Then it goes to point C. C is negative 0.2, so right about there. We'll put C here and put D there. All right, and then at point B, we go to negative 1.95, so right about there. And the bending moment at point A goes to negative 3.45. So A, 1, 2, 3, right there. Okay, so what's going to happen here is it has nothing, and then it gets to point C, and it starts to increase. So here we have, starts like that. Okay, and then we have from, see, actually point D was 0, point C was, so we actually kind of goes like this. Alright, and then at point B goes to this section here, and that's along the uniformly distributed load. So that's going to be a parabola. Okay, and then at point B to A goes to here. So once again, another angle. So we'll do this different crosshatch. Presents the bending moment diagram. So here's our shear force diagram. Here's our bending moment diagram. And that's how you solve that one.